system is cold. If the system is operating, you should be on a pressure on 2.2 bar. Yeah, so around that. The pressure, operating pressure, we are talking about the pressure after the engine pump. So on the way to the engine, we should have at least a pressure of 1.2 bar through the circulation or through the cycle of the engine. Okay, that's the expansion tank. So you get the expansion tank in different volume size. This is the expansion tank for the 300, the HTU 300. There we use 80 liters. So the size of that tank depends on the volume of water in this cycle. So if you have a different cycle with more water, you need a bigger expansion tank. If you have a cycle with less water, you need a smaller expansion tank. Okay, and here on the gas side, that means here we are connected to the water side. So the one side of the expansion tank will be later on connected to the water side, for example here to the HTU unit. The other side is a gas. So it's nitrogen gas, what can be filled and measured here on top on that valve. There's a valve like a usual tire valve from the car. So we can measure here the pressure and can release or fill up the pressure. Important actually is that we use the gas, so the nitrogen gas. If you use the usual air pump, you always get oxygen plus humidity inside. So and that can produce, or if you get oxygen inside and humidity, it can start to rust inside and it can damage the expansion tank. So the best is if you can use gas. Okay, and the important function of an expansion tank is to compensate the balance, or to balance the volume change in a closed water cycle. If you have a closed water cycle and you heat up the water will start to expand. And if the water expands, the pressure will increase. So that we can keep the pressure stable, we put the expansion tank in between, which compensate the volume change through temperature. So very important that in a closed cycle need an expansion tank with the right size. Okay. Here on the expansion tank, on the bottom of the expansion tank, doesn't matter which one, is this is the expansion tank for the HTU with 0.8 bar as gas filling pressure. Then we can check the gas side. So if we like to check the gas side of the expansion tank, first we have to close that cock. That cock is connect the expansion tank from the water side to the HTU water side. If we have continuously the water side connected, we cannot measure properly the gas side because we still have the water pressure on that side that will change the gas pressure on the other side. So we close that valve first and then we release the pressure on the water side of the expansion tank. So that can be done on that here. So we open that small valve here and the water pressure will go out here, and we will not have any water pressure on the water side of the expansion tank anymore. Now we can check here the gas pressure, and we can either release if the pressure is too high, or we can refill or fill up the pressure that we get. The targets here, for example, is 1.8 bar. On the expansion tank of the charge air cooler safety module is 1.5 bar, and so on. Different pressure. Okay, after checking, after releasing the pressure, and we check the pressure, so close the valve here again, and important, before you go back in operation, the valve here must be back open again. so that we connect the expansion tank to the HTU or to the other water cycle which is connected. If this is still closed, we will not have the balance or the compensation of pressure change through temperature. Very important, and for sure, put the wire seal back in again, that we make sure that this stays open and nobody will change it. Okay, now quick break. I have to put up a light. It's getting very dark here in South Africa. 1 second. So, okay. Here it's the primary pump. It's a Grundfos Magna pump. This pump, okay, this pump is speed controlled. So that pump has an internal frequency converter. Internal frequency converter, and can control the speed of the pump, that we get the ideal forward flow temperature for our primary system. And the pump is connected via an analog signal to the PLC. So the PLC control via analog signal the speed of the pump to get the ideal forward flow temperature on different loads of the CHP and get the temperature stable for a nice and the high efficient heat supply to the plant or to the client. This is the STL, so the safety temperature limiter. This limiter is installed on the HTU on the top of the hydraulic separator, what we saw in the previous pictures. So the STB and STL is the same. SBT is the German translation and STL is the English translation. So it's an over temperature switch and protect that we're not getting in a high temperature in the tank, for example, of the hydraulic separator. The limit is set on 110 degrees Celsius. This is the target or the settings of Schnell. I think the most of the system should not exceed 105 degrees Celsius. But yeah, it's the settings of Schnell. If we exceed the temperature, the switch will open the contact and send a digital signal to the PLC, and the CHP will stop with error message or safety chain error and stop the CHP and to release or to reset this temperature switch. We have to remove the black cap here, black or gray cap, and underneath there is like a pressure or a switch what you can press with your finger to reset the switch. We have here the minimum pressure limitator. This was the pressure under pressure or the low pressure measurement tool or switch, what is mounted on the bottom of the hydraulic separator. We have here the small red. In case we have, especially if you have a new commissioning, there will be no water, so no pressure inside of the HTU. That means after filling the water and rising the pressure, we have to reset the switch manually. So you have to do it by hand. There is a small red area behind this plexiglass where you have to press the button to reset the error message on the visualization. The adjustment here is on the scaling. That's actually here. This is adjusted on 1 bar, and the standard bar or the standard adjustment is 0.4 bar as the minimum pressure at the Schnell CHP HTU. If we get below 0.4 bar, this switch will switch off the CHP and will bring an error message. This one, the point where this is adjusted can be adjusted with the screw on top of the sensor. So in case you get one from Schnell, it's not adjusted already, we have to adjust it with the screw, that we come back here to the 0.5, 0.4, that's that level. So we have to adjust that with the screw, that this small joint plate moved up to the right position. In our HTU we have a water flow monitor sensor. This sensor measures the flow through the pipe in the primary circle of the HTU. If the flow is lower than 10%, then either we have problems with our dirt trap, that the flow cannot circulate through this cycle properly, or the primary pump is not working properly, so that the flow rate is below 10%, and if it's below 10% for longer than 20 seconds, there's a delay on the signal, then we will have immediately stop on the CHP and with the flow error message. So that's important. This actually protects the engine, for example, in case that the primary pump is not working, or we have not enough water flow through the cycle that we can actually cool down the engine or keep it on temperature. And if we exceed temperature and we heat up the engine over the limits, we always get issues, other error messages, but we could have damages in the meantime already. So we have here the heat transfer unit again, and here the flow diagram of the older visualization software, and here of the newer visualization software. You can see this, the diagram by themselves, so the flow is exactly the same, only different softwares. So we was talking about already from the actuator valve. So we have this valve not only in the safety module, we have it as well in the HTU. Sorry. So we have it at the emergency cooler and at the plate heat exchanger bypass valve, and what we had already spoken about on the safety module. We have here the flow diagram of the heat transfer unit again. We have here the bypass valve, this is bypassing the plate heat exchanger, and we have here the emergency cooler valve, this is for that cycle. Okay. The third one, what I mentioned already, is from the safety module of the charge air cooler second stage. It's here. It's connected to the charge air cooler to cool down the gas what is going through, and to the radiator cooler on the water side. So the same is for all these actuators and the valves. Important is that we have the right position, so the mounting, that flow rate is right. The other thing, again, we have to keep an eye on how that dip switches and bridges are connected. Our exhaust gas heat exchanger. So the exhaust gas heat exchanger is built to remove or to use the rest of the heat from the exhaust for supplying to the client. On top of the safety on the exhaust gas heat exchanger, we will find a safety temperature switch. Again, there's a gray temperature switch with the red black cap, where we have to reset on that. The important is here as well that we not exceed. So we will have an overpressure release valve. So if again, always you need on a separate cycle or on tanks, you need this overpressure valve. if the pressure in the tank exceeds a maximum pressure, the valve will release the pressure and release the water and reduce the pressure. So we have here a little bit of flow. Please, Schnell sometimes change the design of flow for different versions. So this is a standard version. For example, the red is the supply from the exhaust gas. So this is the inlet. We're running into here. Approximately depends on the version or on the CHP between 400 to 500 degrees. We split that into the two tanks. We run it here through this circulation pipe through the tank. In the tank we have water. We have the water supply on the top. The water runs to the bottom. So the heat from the exhaust gas will now transfer through this ring pipe to the water. From here we're running through the red and going directly through the other pipe up to the exhaust gas outlet. From the other one runs down like that through the ring pipe, goes back to the other and goes up. Both pipes later on will be connected to a center pipe and goes to the silencer and up into the air. So the exhaust gas outlet approximately will be 180 degrees. We don't should cool down the exhaust gas too much, otherwise we get into the area where we get condensate in the exhaust gas pipe. With the system here, we're running here the water next to the pipes of the exhaust gas, heating up the water. The water runs through into the next tank, runs out of that tank. Means we're heating up from the exhaust gas from the first turn pipe to the next turn pipe, so and can remove an additional heat of plus 10 degrees forward flow temperature. So we're getting an additional heat of the exhaust gas, which we supply to the primary circle of the CHP, what then gets supplied to the client if they're needed.